Hi all, and welcome aboard to talk about service buses. My name is Robert. I come from Serbia. I'm a PHP developer for the last 10 years or so. I'm a core contributor to the mockery, the mocking framework for PHP. So if you have any problems with that, find me after the talk, of course. I also currently learn about Go, so that's a cool language. I like to write a lot, so I write a lot on my blog about programming-related stuff. I like to play board games a lot, and I blame that person there. And for the past 8 or 9 months, I joined a group of people to play Dungeons and Dragons. And last night was my first session I missed, and I missed it because of this conference. This windmill is a windmill in my hometown of Bačka Topola, and it's one of the 11 remaining windmills in my country. And we had 282 windmills, and they were all built based off Dutch windmills. So yeah, we're also a windmill country. So what we're going to talk about today. First, I want to give a short introduction to set the stage for the talk, then talk about CQS and CQRS a bit, and then practically dive into service buses and the 3 types of service buses there are out there: command buses, event buses, and query buses. So I guess we've all been involved in all kinds of projects. You get a new project, you're excited, and you agree with the client what features they want, and you agree on the deadline and on the budget, and you're excited, you're smart, you're capable, you're gonna do all the best things, and you're just gonna apply all the best practices and design patterns, and it's gonna be perfect project for you. And you work on it for months and years, and the deadline approaches, and you deliver the project, and there's 3 bugs in there, but nothing critical. And then you step back and take a closer look at the code base, and it's, you did it again. It's it's a huge mess, and what's going on? And I guess to some extent, this is the nature of our industry. We blame our clients, they changed their minds on the features, they added new features, they moved the deadline, they cut the budget, they did everything to make our work even harder. And I guess all those people at conferences and blog posts, books, they all lied. That's really not a good design pattern, not the best practice. So you're gonna learn from this mistake. You're gonna go to more conferences, listen to more best practices, design patterns, and the next project is going to be the best project. So today I want to talk about one of these design patterns. It's called Command Query Responsibility Seggregation, or CQRS for short. But before that, there's an older design pattern called CQS, or Command Query Separation. And this older design pattern says that if you have a method in your class, then that method should only either change the state of that object or of an application. So it should do writes only, and we call those methods commands. It should return nothing. It should have a void return type. Or a method should either read something, query the state of your object, of your application, and it should have no side effects. If you query something, don't change anything by accident. So CQRS, which was based off of CQS, and it's different enough to earn its own separate name as a separate design pattern. It's built on top of CQS. And what CQRS says basically is that if you have a class full of methods that do both reads and writes, then we should split that class into 2 and in one class have only the methods that write, and those would be our command classes, and in a different class only the methods that read, and those would be our query classes. And with this, we could get sort of a better separation of responsibilities in our code, and code would sort of follow the use cases of the application more closely. You know, we completely split the concerns of the two classes. We get easier maintenance, better performance, because once you split the write side and the read side, and mostly in the context of web applications, which I believe most of us develop, that are backed by relational databases, we can take that write side and continue writing into a third norm relational database, you know, MySQL, PostgreSQL, whatever, and then split off the read data store, create specific read models that are for like one page, one view, optimized. So we denormalize the third norm, completely denormalize it, and create read data stores. It can be MySQL, it can be a document database, it can be Elasticsearch or whatever. And this way you get, you know, a better performance, because now the read side of your application is optimized for reading and not for a little bit of writing, a little bit of reading. So even on that level, you get a separation of concerns. So take, for example, this example of code. You know, it's a pretty standard sort of code to find in legacy applications these days. You know, think Zen Framework 1 or something like that. So you have a class called product with a method called update. It receives a product. So you see that and we're gonna update the product here, right? We can update, well, I guess a price. We can maybe update the title, the description, the keywords of that product. But this is a web store. We're building a web store. So web stores should probably support multiple currencies. Like, how do we update prices for, you know, in multiple currencies? We don't, like, is this somewhere maybe hidden in that database update call? Or maybe does that happen in a layer above? We don't know. And this is just like a short snippet of the code. Usually these methods like have some kind of validation check, like, is the title empty? Or is it over, I don't know, 200 characters? Is the image of a correct size and a correct extension? And it would be all in that one update method. So again, you come to this method and you want to make a change to it, like, oh, it's horrible. And there's a bug in that code, in that sale equals 1 and checking the price. There's a bug, and it's pretty hard to see it. Does anyone see it? Yeah. It's not strict. That's one bug. But there is, like, this business logic, this allows to update the price of the product if that product is on sale. It's a business people made up this rule. Like, if the product is on sale, we don't change its price. But what if in the same update call, we're also changing that product from not on sale, from on sale to not on sale? Right? Because then pre-sale product sale equals 1, it is 1. But we also need to check, like, is the currently updating product being removed from sale? Now, if we take the CQRS approach and go all the way, we could, for example, create and take that one use case of updating the product's price. So we focus only on that use case. We don't care about titles and images and keywords or categories or whatever. We care about only the price of the product. We could create a command, which is pretty much a data transfer object, a DTO, which takes in the price, the currency, and the product for which we are updating the price. We expose those two things. We create a price value object. We expose them through getters. That's it. So that's all there is. There's no missing pieces in this code. Maybe some comments. On the other hand, we would have a command handler that can handle this command. Again, it receives the command, checks the sale flag, checks the prices, business logic is OK. Sure, update the price, save it to the repository, done. You don't have to think about like what's happening with the images. This is the use case we're talking about, the only use case, updating the product's price. It's really easy, really nice to maintain, really testable code. So the good parts of CQRS is that we get smaller classes because they do a lot less. Because they do less, they have separated responsibilities. If we end up splitting the write side and the read sides, the write and the read data stores, we get better performance. And if we optimize the read models for reading, then we don't have to join 6 tables anymore to show one report. We have all the data that we need for that report in that one table. And going back to the use cases, like I worked on a web store, and the admins had like this huge form, product title, product description, product keywords, category, images, prices, flags, this, that. And when we talked with them about how they use that form, turns out they had a team that was responsible for making sure that the images are nice and big, that the customers can see the details on that of those products. They would have a different team that would deal only with the pricing of the product. They would have a different team that would be responsible for the SEO, so they would make sure that the keywords are correct and really nice and searchable by Google and stuff like that. And everyone was using the same form. So we built them like this huge form, and like they were using only one tiny piece of it. They had a different use case for it. So we then took and, okay, you're in the SEO team, you get, textual fields. You're in the pricing team, you get, price and currency. That's the use case. And from that, we could really, that's where the strong point of CQRS came in, because all they wanted to do is update the product's price. And the code base was doing only that, nothing else. And when they were like, hey, there's a bug, with conversion from euros to dollars, there's one place to look at. And you're looking only to that. Yeah, you don't have that noise like, oh, there's the title validation, there's the image validation. No, it's only the validation for prices. Of course, the downside is like you now have a lot more classes, to look at. There's this translation or projection or denormalization from the write side to the read side, and that can turn to be quite complex when you have to sync the write data stores and with all the read data stores, and it's eventually be going consistent, but not really now. So you have to deal with those kind of things. Now, Service Bus is basically a system that allows us to implement the CQRS pattern. We don't have to use the CQRS, but I found it's really nice. It makes the process of implementing CQRS much easier. So it's basically a messaging system which takes a message from one part of your application and then dispatches it to a different part of your application. And in the context of CQRS, a command is a message and a query is a message. And there's different types of service buses, which are different based on what message types they support. So if they support command messages, then they are command buses, and event messages, event buses, query messages, query buses. In PHP, the libraries, they vary in the type of the messages that they support. So for example, Tactician, I thought it supported only commands, but turns out it also supports queries, which I didn't know. I was using it only for commands. Simple Bus supports commands and events, and Prooph Service Bus supports commands, events, and queries. Their principle of how they work is pretty much the same. It's basically just a for each loop, going over your messages, dispatching them. So depending on your needs, maybe if you only need a command bus, then you could go only with Tactician, or if you need all 3 buses, then you could go with Prooph Service Bus. There's plenty of choice. So a command bus, it takes a command and dispatches it to command handler. Simple. The main characteristic of a command bus is that every command that you dispatch on the command bus has to have exactly one command handler capable of handling that command. So, yeah, was that hard to understand?
No, it's okay.
So there's a one-to-one mapping. You cannot dispatch a command on your command bus and not have a command handler who can handle that command. The command bus would throw an exception. And you also cannot have 2 or 3 command handlers registered to handle the one and same command, like who's gonna win in this battle. And if we stay true to the nature of CQS, then command buses should have no return values, but that's not a hard set rule, like do whatever you want. Like that's how actually Tactician supports queries, because it has return values, so if you return, then practically that's a query. If you're not, then that's a command. I'm on the side that I don't return anything from a command bus, because I just found it, better mental model for myself, like how do it's a command and it needs to happen, and it happens. It can be synchronous or asynchronous, and that's actually all types of service buses can be synchronous or asynchronous. But in case of command buses, it's better to be synchronous. I never came across the situation where I would need an asynchronous command bus. Maybe if you have to throttle, like the coming in command requests, maybe then you would use asynchronous command buses. But so far, I've always been with synchronous. And the reason is that a command wants to do something with your, a user wants to do something with your application. And it commands that application, like, create a new product. And they want it done, like, now. So we use commands for user actions, like when the user wants to do something with our application. Now, I said there's no return values for command buses, or there shouldn't be. So the next best thing we have is that the command bus, actually what the command bus needs to support is to notify us, was the handling of the command successful or not? And basically, if there's no exception, then everything is okay. The command went through. And if there's an exception, well, something happened. Catch it, display an error to the user, maybe retry the command a couple of times, fail after, 5 tries. So we use command buses to change the state of our application, to write data into a data store. And I said, Tactician, Simple Bus, Prooph Service Bus, they all support commands. So they're all in some part command buses. Now, commands themselves, they are messages about what our user intends to do with our application. Like if they want to create a new product, then we would have a command called create product. Or if they want to put product on a sale, then we would have a command put product on sale. And these names reveals the use cases of our application. Or better yet, the use cases of our application will name our commands. And this is really good because if you have a folder, like that's where all your commands are, then you just look at the names of the commands in your directory structure and you have a pretty good guess of what can you do with that application. You can create a product, you can update its price, you can put it on sale, you know, stuff like that. And note that there is no and or in the names of these commands. So the user never wants to like create product or upload an image. That's not a thing. So one command equals one action, and that's it. Another important thing about commands is that they are always valid. Meaning, if for whatever reason the data that you're passing in to the command is not valid, for example, creating a product and you pass in the title is empty string, throw an exception. Don't create a command. And here in this case, like we pass in the price and the currency, we create a price value object out of it. Maybe the web store supports US dollars and euros. Someone passes in, you know, Canadian dollars. The price value object will see, okay, we're not supporting Canadian dollars, throw an exception. That will fail the creation of the command. And suddenly you cannot dispatch that command. And that's really powerful, and I'll say why in a couple of slides. So, as I said before, assign it to some properties, make them, you know, through getters available for the outside world. Once you want to dispatch a command, you get the stuff you need, for example, in an HTTP controller, the stuff you need from the request, create the command object. Okay, there's like a try-catch block missing here. If for some reason the creation of the update product price command fails. But if it's created, dispatch it on the command bus. The command bus will find the appropriate command handler and tell it to do its job. If we want to do the exactly same thing in a CLI script for some reason, it's the same. The only difference is where do we get the input from. In an HTTP case, that was like a request object. Here it's like an input object. There's no difference. Now, once a command handler receives that command, this is where the always valid command comes in. Because now the command handler, he's certain, like, I received this command. This command, by the mere fact that it received that command, it knows that command is okay to be processed. And it knows that every data that command carries is correct. It knows that, for example, there's not a negative price in there, or there's no, you know, foo it doesn't have to do those kind of checks because it received a price value object. And we know if we have a price value object, then that's a valid price in our store. So it's free to do that one thing only, and that's like accept or reject the command, because it still can reject it. Like maybe the update product price command is not acceptable in the cases when the product is on sale. Like the product is on sale, we cannot update the price of the product. Exception. But if it can accept it, then update the product's price and save it to the right data store. Really nice, really simple, testable, just a joy to work with. Now, events, they don't really appear in the CQRS design pattern, but I think it really completes it and complements commands and query quite nicely. And just because there's the name of event in it, it doesn't mean you have to do event sourcing to be able to use events. That's not the only purpose for events. And also, I forgot to mention this in the beginning, most talks, like mostly people talk about CQRS and event sourcing together. You don't have to do CQRS and event sourcing. You can do either or both or whatever you choose. So when we want to dispatch an event message, unlike the command bus where every command has to have exactly one command handler, an event, 0 or more event listeners. Like either someone cares, or either no one cares, or either many things care about this event happening. It's up to the business side. And I'm not sure if you attended Sean's talk, just the slot this before. That was a really good talk about the use cases of events and how we can use them to decouple our application better. So if you missed it, make sure to watch it on YouTube when it's available. So practically, we would send these events between different parts of our application, between different, if you do DDD, then between different bounded contexts. You would use these events to notify, like, hey, something interesting happened here, and whoever cares about that, feel free to respond it. In PHP, there's Simple Bus and Prooph Service Bus that support events. So these events, the messages themselves, they're always about past events, about things that happened. I almost always use them after a command was handled. Like once a command was done, like that's the thing that our user wanted to do. So it's safe to assume that it's an important thing in our application, in our business logic. So command got handled, trigger an event. For example, if they created a product and the create product command was handled, issue an event product created with all the details that are important. And if the product's price was updated, product price updated. And the thing about events is that once they are dispatched, they cannot be stopped. You cannot prevent events from happening. It's in the past. It already happened. The only thing you can do is deal with them. And no matter how many event listeners you have listening for an event, one event listener cannot in any way affect that event that would endanger other event listeners from receiving that event. Like one event listener might decide, I don't care at this moment about this event. That's perfectly fine. But it cannot prevent other event listeners from receiving that very same event. And also, one event listener shouldn't modify any kind of data within that event. And finally, because there can be more than one listeners listening to an event, your application shouldn't care about the order of event listeners. Like who gets the event first? Doesn't matter. They all care about that one specific event for their own specific reasons. So who gets them first? It shouldn't matter. So if you find yourself in a situation where you realize that the order of event listeners is important, then you probably have something else going on there. So double check that. Again, events as messages, as objects, as DTOs, they should always be valid. But so far, I found it better to transfer only primitives within events, because this way you can serialize them without being afraid that you will break something in 2 months. And this allows, for example, say you're on a site and there are users registering, and the owner of the site wants to know how many users registered over the day. You wouldn't send out an email to him like every time a user registers. That would like make him like mark as spam his own site. But you could queue or aggregate those events and then just do a final count at midnight, send out one email, hey, today you got 122 new users. So holding primitives within these event DTOs allows you to do that, and that's a powerful thing. Dispatching events, as I said, at the end of the command handler, when a command handler has done completely everything that it needs to do, saved to the database and updated stuff, once there's nothing else to break, then you create the event message and dispatch it on the event bus. Now, take for example that our client decided that whenever there's a price drop in any product, they want to do some marketing and tell all their previous customers about this price drop. Like, hey, this hammer is now €2 cheaper. It's a perfect time to buy yourself a new hammer. So once the update product price command gets handled, we dispatch an event product price updated. And yes, we care only about the price drops, but the thing actually that happened was that the product price was updated. Just because we have this one feature that is interested in price drops, it doesn't mean we should send some kind of a different event. The thing that happened was product price updated. And that's what we were telling the world, like, this is the thing that happened. The event listener notify about price drop. It will receive that event listener and decide for its own, is it interested in that event or not? Maybe the old price is smaller than the new price, so it means there's a price increase. I don't care. I go home early. But if there's a price decrease, okay, get the information about a product, send out an email, or do whatever you want. So this is what I meant, like an event listener cannot prevent other event listeners from receiving this event. It's like, I don't care about this event if there's a price increase. Maybe there's some other event listener that cares about only price increases. So it would have the check turned around. And finally, query buses. And they're probably the least used, not probably, they are the least used query buses, service buses out there. And I guess many people don't see the benefit of query buses. I'm probably one of those as well. Like, I started using them just to figure out like what's good and what's bad about them. So far, it's just mainly more typing. So as we use the command bus to write, we would use the query bus to read stuff. And again, one query message has to have exactly one query handler, and just like the command bus. But the difference from a command bus is that a query bus must return a result, or throw an exception like I cannot handle this query at this very moment. Prooph Service Bus has a query bus, and as I said, Ross told me last night that Tactician does indeed support queries, so there's Tactician as well to use as a query bus. Now, when I say query, it's not a database query. It's not, you don't write SQL here. A query is a question that the user has about our application, about their data in our application, about the state of things. Maybe they're interested in what are the latest products that were created between, a time frame, or what products are currently on sale, or what's the sales report for the past quarter. Those are the questions users have, like, I've done that. Now, what's the effect of it? And this is my question. What's my result for that? And mostly we would get the answers for these queries from the read models. Again, a query is an always valid object, just like commands and events. I'm still not sure it should be like primitives only, or can it support queries, non-primitives, like different objects. I'm currently in the process of using objects and nothing's broken, so I guess it works. But mainly because I don't do any queuing of queries. If I would queue them in a message queue like RabbitMQ, then probably using primitives would be a good idea. Dispatching, just like a query, just like a command or an event, create a query message, dispatch it into the query bus, and wait for the result to get back, and then do that, pass it to the template, turn it into a JSON response, whatever. Query handlers are, so far for me, they're nothing spectacular. So this probably explains the reason why people don't use query buses, because I could just easily do the whole products bought read model fetch in the controller and not create a query and a query bus and a query handler and then return. Too many steps. But I currently do this just to experiment and see what's happening. At the first meetup I gave this talk, an attendee afterwards approached me and said that, like, I'm not sure it's Shopware or Shopify, or like it's like an e-commerce thing. They use query buses and they practically use it for the sake of throttling incoming requests from users. So that can be a good thing to use query buses for, I guess. And also maybe you have some weird case where you have to query something from your database, and then you have to go out to a third-party API service, get some data from them, then query another database, and then make a huge result out of that, and then return that. Like in those cases, yeah, query bus would probably be a good thing. But other than that, my query handlers pretty much look like this. So takeaway, command query responsibility segregation, to use it when you see use cases like a flow, of your application, and use it to split the responsibilities of the classes you have. Like if you see like it's a huge God object or a God class that does way too many things, see if maybe this splitting on, like, let's just do writes here and reads over there, maybe it makes it more easier to maintain. And when you have, like, CRUD is okay. This is not a talk against CRUD, but in some cases, like we had in that huge form, which was like a CRUD, it turned out that it was suboptimal for how the users actually use that form. So maybe if you run into those kind of situations, maybe again, CQRS and the whole service bus thing would be good for you. Use events to notify about important things, like user registered and you want to send them a welcome email. It doesn't have to be in the same blob of code. You can trigger an event and then in an event listener send out the welcome email. Just don't send plain text passwords, please. And use queries to answer questions about things that users have questions about. That was weird. Use queries to answer user questions about your application. Finally, Luis Cobucci, please wave. I see you there. He started a project called ChimeraPHP. It's okay. It's pretty much a middleware-ish framework that's supposed to, for example, you take a route and you configure it like this route has this command and this command handler, and then ChimeraPHP provides all the plumbing. Did I get that right? Sort of. Yep. And it uses PSR7, PSR15 middlewares to connect it all together, right? And then have content negotiation policies and stuff like that. So, you know, take a look at it. Help out Luis. You know, I think it's a good idea, nice idea. I hope it will grow to something bigger. So kudos, Luis. Thank you.